Okay, so day 3, part 2, we're going to learn about linear programming. So what you want to do before you watch this video, you want to either print out the 2 documents that go with these notes, which are the linear programming skeleton. You're going to want to print out 2 of those for the notes, and the word problems. If you don't have a printer and you can't print it out, make sure you write everything down, okay? And then go back to the video. So have those ready to go, okay? And so now we're going to learn about what is linear programming. And it's one of my favorite topics to work on, okay? So linear programming indicates linear, okay? So what we're working with is going to be linear. And when you are dealing with linear programming, you have a problem, okay? And what you're going to want to do is that needs a solution that maximizes or minimizes that need. So, for example, a company sells 3 types of toys, okay? And the company wants to maximize their profit selling those 3 toys. That's a linear programming problem. So what you will have when you have linear programming, okay, when you try and maximize or minimize, maximize means you want the highest amount, minimize means you want the lowest amount. So another word is called optimize. Optimize means you want the optimal solution, the best solution. So sometimes maximum means the best when you're talking about maximum profit, okay? If you wanted to, let's say, minimize the cost to you, okay, that's still optimization. You want the minimum cost because that would be the best cost for you. So when you have a linear programming, the first thing that you have is variables, okay? Your variables are going to be how you will, let's say, if this is a problem about maximizing profit, your variables are how you make the money, okay? So I shouldn't say, actually, I'm going to erase how you will and write that is the independent variables. Okay. That make, we will say, your optimum equation. I guess we can use, actually, let's not say that. Let's say your objective function, okay? So you're going to have an objective, okay? Maximize profit. How are you making money to make a profit? What are you selling? Those are your variables, okay? After you identify your variables, okay, you need to write your objective function. Okay, so let's say we go with that maximize profit. You have 3 toys you're selling, you maximize your profit. Okay, for every toy A you sell, you make $5 in profit. For every toy B you sell, you make $7 in profit. For every toy C you sell, you make $9 in profit. So your profit equation, your objective function, would be 5 toy A plus 7 toy B plus 9 toy C equals profit. That's how you would be making your money, okay? And so after you have your objective function, okay, now what's true about linear programming is, okay, you have these variables that are getting you this objective that you want to reach. So like you want to maximize profit by selling these 3 toys. But what the problem is with linear programming is you can't make, okay, in real life, you can't make an infinite number of toys. So you're never going to be able to make an infinite amount of money. So there are restrictions, okay? You have to identify all constraints. Constraints are just restrictions, okay? You have to write them as inequalities. So what that means is, here's an example, okay? Your factory in which you make your toys cannot be open an infinite number of hours, okay? It might only be able to be opened, let's say, 6 hours a day. So you have a constraint on how much time that you can spend maximizing your profit because you can't spend forever making those toys. Also, you might have a certain amount of money that you can spend to make the toys. So you have to make sure you're not going over the amount that you're allowed to spend on those toys. So those are all considered constraints. Now, what you do is, when you do this by hand in this class, okay, if there is computer software that does this, okay, but we're gonna only have 2 variables, which means we'll be able to do this on a coordinate plane. You can have much more than 2 variables. In my example I just gave about toys, that's 3 variables here, okay? But that would have to leave off of the coordinate plane, so you wouldn't be able to do that by hand in this class. You'd have to use a computer software. And so what you do is, you graph your constraints, and you do what something is called, and you identify the feasible region. Okay? Your feasible region is the true area, okay, or the solution of constraint inequalities. Okay? You know from Algebra 2 how to solve a system of linear inequalities after you sketch them. So your feasible region is the solution of your constraints. Those are all of your possibilities, okay? Then, number 5, okay, something called corner points, okay? What you do is, you identify your corner points of your feasible region. Okay, and that is because max or min always occurs at corner points. Okay, that has something to do with the slope of a line and identifying the maximum and the minimum. We're not going to get into that, but what you do need to know is the maximum and the minimum, okay, the solution to your problem will always be at a corner point of your feasible region of your constraints. So your constraints is going to give you a region, okay, of all possibilities that meet all of your constraints, okay? But you want to know how many of toy A, toy B, toy C should I make specifically, not just so I meet all the constraints, but so that I make the most money. That's going to come from a corner point on your feasible region. So the feasible region is all the possible toy A, toy B, toy C's that I can make that satisfy your constraints. And then the corner points are going to be where the maximum profit is, where the minimum profit is. So then, what you do is, you take those corner points, okay, number 6, is you take the corner points, and you plug them in to the objective function. Okay? This is called the optimizing part. Okay? You're taking all of those corner points and you're figuring out which one gives you the maximum or which one gives you the minimum, and then number 7, you answer the problem. Okay? So, here we go. Those are the steps. I know we wrote them down. Might not make much sense to you, so it really starts making sense once you start doing these problems. So I'm going to erase the board. And what you should do right now is look at problem number 1 from day 3, part 2 problems, okay, which is a farmer and have a skeleton ready, okay? So read over, okay, pause the video, read over the farmer problem, okay, and then play the video, okay? So it says a farmer has asked you for advice on the best strategy for planting wheat and corn on her 500-acre farm. To make it through harvest time, each acre of wheat she plants will require 1 person day of labor and other expenses of $20. Each acre of corn she plants will require 5 person days of labor and expenses of $30. The farmer has 11,400 and 1,480 person days of labor available, and she expects to make a profit of $90 per acre of wheat and $120 per acre of corn. Okay, then it says part A. What are your variables and what do they represent? B, write the objective quantity equation. That's the same as the objective function. C, write the system of inequalities that describes the constraints. D, graph the system of inequalities and find the vertices. E, how many acres of each type of crop should she plant to maximize her profit? What is the maximum profit? So that right there is our objective. That's what we're trying to do for this farmer. We need to tell her what the maximum profit will be and how many acres of wheat she should be yielding and how many acres of corn she should be using. Okay, so that is how she is making money, right? How is she going to make a profit? She's going to be selling wheat and corn. Okay, so you can follow along. I would write all of this on your skeleton. So notice your skeleton says problem. I would write day 3, part 2, farmer. Okay, that's your problem we're working on right now. And then it says define your variables. So let's define our variables for this problem. Now, our variables, okay, below variables it says state the objective function. You need to think about what your objective function is before your variables, because your variables are what's making the objective. So you're trying to maximize your what? You're trying to maximize your profit. So your objective is going to be to maximize your profit. Okay, so this is going to be an equation. Your objective function is going to be how you are making a profit. Now, how are you going to be making money? You are going to be selling wheat and corn. So those are your variables. Okay, now look, it says acre of wheat, acre of corn. So W will equal the acres of wheat, and then we'll let C equal the number of acres of corn. And so how are you going to make money? Well, for every acre of wheat, you make $90, and for every acre of corn, you make $120. So that would be 90W plus 120C. That's your objective function. What's your objective? To maximize your profits. You have to write an equation of how you are going to make a profit. 90W plus 120C. For every 1 acre of wheat, you make $90. For every 1 acre of corn, you make $120. Then it says, what are your constraints? Okay, so why can't you have an infinite amount of acres? Okay, well, let's look at the problem. So it says, okay, you might want to, before we write the linear inequality, you might want to put it in words. Okay, so it says she only has a 500-acre farm. So she can't make 700 acres of corn because her farm is only 500 acres. So we know that we have a total acreage, okay? And we're not going to be able to go over that. I think that's how you spell acreage. Why don't we say total area? Not sure how to spell acreage. So, we know in total she has 500 acres. And so, for every acre, right, we add them up, it has to be equal to 500. Now, that means that that's W plus C. But is it okay if we are less than 500? Yes. But can we be more than 500? No. If you don't like seeing it like this, you could just write it like this. W plus C has to be, whoop, not greater than or equal to. That's why it just messed me up. Okay. Less than or equal to 500. Okay. We can't go above 500 acres because she only has, look at the problem, the farm is only 500 acres. So we know that the amount of acres of wheat plus the amount of acres of corn has to be less than or equal to 500. It's okay if we don't use the entire farm, but you can't use land you don't have. And now the next constraint has to do with labor. Okay, it says that we only have 1,480 person days of labor available, so we can't go over that. And every acre of wheat requires 1 person day of labor, and every acre of corn requires 5. So 1W plus 5C has to be less than or equal to the total number of person days available, which is 1,480. Then we have expenses. It's going to cost money to keep up with the land, okay? And we don't have an infinite amount of money that we can spend. So it says we can spend $11,400, and the expense for an acre of wheat is $20, and the expense for an acre of corn is $30. So that would be 20W plus 30C is less than or equal to 11,400. Now, there is another set. Now, if you look at this, you're not going to see anything else, okay? We hit all the constraints. We have a finite amount of land, we have a finite amount of labor, and we have a finite amount of expenses, okay? Amount of money we're allowed to spend. But there's something that you need to put into this problem, okay, that it's not going to just be out in front of you in the problem. And that is that you can't have no negative acres. So what that means is W has to be greater than or equal to 0, okay, and C has to be greater than or equal to 0. You can't have a negative amount of wheat acres, and you can't have a negative amount of corn acres. Now, why do we have to put these in play? Well, because if this was negative, like -2, this can then be 502, which you can't have, okay? Because that would still be equal to 500, but you know you can't have, that doesn't make any sense. So you can't have a negative number of wheat acres, and you can't have a number of acres of corn. That's negative. And don't write W plus C, okay? No, this is a no-no, okay? Do not write this, because this is saying that W could be -5 and C could be 5, okay? Do not put this. Each of them need to separately be greater than or equal to 0, okay? And so now what we do is we take these constraints, okay, and we need to graph them. So let's write them down, okay? W plus C is less than or equal to 500. W plus 5C is less than or equal to 1480. 20W, you already have these written down. I'm just writing them because I'm going to erase the board. Okay, W is greater than or equal to 0. C is greater than or equal to 0. Okay, I'm going to erase the board. Now, on your skeleton, you have a nice piece of graph paper there for you. So, notice, your graph paper looks something like this, right? Now you need a W-axis and a C-axis. So we'll call this the W-axis down here, and we'll call this the C-axis. Now, what these two constraints are doing, W is greater than or equal to 0. That's cutting off, okay? If you imagine your coordinate plane would really go this way, okay? Here's your center, origin of your coordinate plane. These two constraints are saying that you have to have a positive number of acres and of wheat and positive number of acres or no acres of all of wheat and corn. So down here would be negative corn acres, here would be negative both types, and here you would have negative wheat acres. So what these two do is put you in quadrant 1, so you don't need to draw the other quadrants. When you have a linear programming problem where there's no way these can be negative in real life, okay? So it puts you in quadrant 1. Now before you start plotting these, okay, don't do them one by one and sketch them. Find, we'll call this 1, 2, 3. Okay, we don't have to write 4 or 5 because we already have it here. Find all the information so you know what you should be going by, okay? So know what you have. So we have W plus C is less than or equal to 500. So the best way to graph this is intercepts, right? This is standard form, okay? This is a linear inequality, okay? We went over this on day 1, sketching a 2-variable linear inequality. And so first thing you need is the boundary, right? So this is W plus C equals 500. You want the W-intercept, you want the C-intercept. If you get confused and you don't like WC, okay, you can just write X and Y and then replace all the W's with X and the C's with Y if that helps. Okay, but just know it doesn't always have to be X-axis, Y-axis, it could be any letter. So the W-intercept is going to be, what's W when C is 0? So W plus 0 equals 500. So your W-intercept is 500. So that's going to be the point 500 comma 0. Your C-intercept is going to be, what's C when W is 0? So that's going to be 500. So notice, if you put this as your W-axis and this as your C, that means a coordinate point is going to be W comma C, okay? So 0 comma 500, okay? So we can see that this line, we need to make sure we show these points. Those are going to be important. So now we have to do the same thing with the next constraints. Didn't give myself a lot of room here. W plus 5C is less than or equal to 1,480. Okay, so you might need a calculator here. Do these problems. So standard form again. So you want, best way to graph this thing is going to be getting the intercepts. So we want the W-intercept. We want the C-intercept. So the W-intercept is going to be W plus 5 times 0, right? So 0 is less than or equal to 1,480. So, whoops, I didn't mean to put less than or equal to because we're getting the intercept, so that should really be an equal sign there, right? We're talking about the boundary. So W is 1,480. So that's the point 1,480 comma 0. And now the C-intercept, we let W be 0. So that's going to be 5C equals 1480. And so C equals, let's see, it's going to be 2. That's going to be 9. Right? 48. That's going to be 3 left over. 296. So it's going to be 0 comma 296. So these are the intercepts, W-intercept, the C-intercept. And number 3 is 20W plus 30C is less than or equal to 11,400. So we want our W-intercept of the boundary, our C-intercept, because this is standard form, so how the best way to graph this thing. So we've got 20W plus, that's going to be 0, right? 30C becomes 0, so 20W plus 0 equals 11,400. Okay, we divide that, and that gives us 570. Okay, so that's going to be 570 comma 0, and the c-intercept is going to be 20 times 0 plus 30c, so that's going to give us 30c equals 11,400. And that gives us 380. So 0 comma 380. So now we can see the largest number we have to get up to for W is 1,480, and the largest number we have to get up to for the c-axis appears to be 500. So we just have to make sure we pick increments so that we get there. So I think if we go by 200, we'll be okay. So this is acres of wheat. This is acres of corn. Okay, label everything. Okay, this will be 200. This will be 400, 600, 800. So on your marker, I think you could do maybe every other one, or you could probably go by 100s. Every tick mark can be 100. Along the W, and then you might want to do 50 for every tick mark along acres of corn. Okay, so that's going to be 1,000, that's going to be 1,200, that's going to be 1,400, that's going to be 1,600. Okay, and I'm going to go 100, 200, 300, 400, 500, 600. I don't think I have to go by up any further than that. Nope. So let's graph the first inequality. Intercept 500. Okay. C-intercept 500. And I connect. Now this is a linear inequality. So you have to shade. Okay. You either shade to the left or to the right. Now think about this. Do you have an infinite amount of land, or do you have a specific amount of land? Up here is infinity, right? Can you have an infinite amount of land, or do you have a specific amount of land you can't go over? Specific, so that's the first. Now, number 2, the W-intercept is 1480, so over here. Oh, and it's not. This marker is dead. 1480. And the C-intercept is 296, so right about here. So if I connect those, okay, now for this second inequality, okay, this one had to do with the labor. Do I have an infinite amount of labor? That's how I think about it. When should I shade above this line or should I shade below? Okay, here would be an infinite amount of acres of wheat, an infinite amount of acres of corn. Can I have an infinite amount of that? No. So I'm shading below. If you wanted to be precise about this, okay, you can plug in a point. I would plug in 0, 0. Okay, does 0, 0 satisfy this constraint? Yes, it does. So you should shade towards 0, 0. Now, this is a system of inequalities, and you should remember from Algebra 1 that a solution to a system of inequalities is the area that they have in common. So right now, this area all over here, they do not have in common. This area here, they do not have in common. Okay? And let's get one more up there. We got to get this one, 570. Okay, now this right here is 500, so this is 570, and 380 is right here, okay, and so it looks like, whoop, this, okay, now, where should you be shading for this third constraint? Okay, should you be shading above the black line or below the black line? Well, test a point, 0, 0. Does 0, 0 satisfy this constraint? Yes, so you should be shading towards. Okay, and now we have to figure out the area where you shaded for all three. Okay, so if you notice, okay, this region right here. Now, be very careful. You don't want increments that are too big, meaning you want to try and make this region as big as you can, because what you need to see here is your region that you have, your feasible region, okay? You have to be able to identify the corner points, all right? I've got a corner point. Here's one of the corner points of the feasible region. Here's another corner point feasible region, okay? Now, look, this is the black line, this is the green line. Here is another corner point, okay? There's another right there. And then this green right here is another corner point, and 0, 0 is another corner point. So you end up having 1, 2, 3, 4, 5 corner points. Make sure you have it. Now, using a ruler for these problems is going to make this a whole lot easier. Now, if these are looking really close, you can't see that, okay? If you can't see that there's a difference here, that means your increments, you need to make smaller increments. So instead of going by 100, you might have to go by 50, okay? But you should be able to see this if you made every increment go by 100 along the w-axis and every increment go by 50 along the c-axis. So, now that we identified our feasible region and we see our corner points, our 5 corner points, we need to get those 5 points, okay? And I probably should not have erased that information, but that's okay. So, this corner point right here, okay, that corner point, you know, is 0, 0. So I'll put a 1 there. Now this corner point right here, okay, this was the C-intercept of this line, right? The C-intercept of this line. So you already know what this point is. I just erased it so I don't have it with me. It's 296. So you know for sure already that that's the point 0, 296. So that's corner point 2. Okay? Now corner point 3, we do not know that, and you do not guess based on what you think it is. Corner point 3 is the intersection of 2 of these. So what we have to do is we have to solve a system of equations to get that exact intersection point. So we have to see, okay, the blue line was the second constraint and the black line was the third constraint. So it might help, okay, when you are doing these problems to have colored pencils. And then what you might want to do is when you do the different colors, okay, so this was in green and I would put a little mark there. We did this one in blue. And then we did the third one in black. That way, when we go to get the actual coordinates of the corner points, we could say, okay, this intersection point is black and blue, so that intersection point is coming from the intersection of these 2 lines. I don't care about the inequality part. I care about just the lines right now. So W plus 5C equals 1480. And 20W plus 30C equals 11,400. And so what we have to do right now, okay, is solve this system. So we have to do a little bit of substitution elimination. So I'm going to multiply this equation by -6, and I'm going to get rid of C. So that's going to give me -6W minus 30C equals 1480 times 6 is going to be -8,880. Okay, so now we add these together. We get 14W equals 11,400 minus 8,880 puts us at 2,520. divide that by 14, and we get 180. And so we know that the W-intercept, remember when we write these down, it's W comma C. The W-intercept for number 3, corner point 3, is 180, comma, now to get the C-intercept, just plug that back into one of the original two. 180 plus 5C equals 1480. Okay, take away 180 on both sides. So that's going to put us at 1,300. And divide by 5, and that puts us at 260. Okay, now I'm just going to erase all this work so that I have room to do what I still have left going on here. Okay, so corner point, that was corner point 3. Corner point 4 is the black line with the green line, okay? That is an intersection point, and you do not know that off the top of your head. You don't have that written down anywhere, the intersection of the black line and the green line. So we got to write down the green line's inequality, okay? But we don't care about the inequality, it's equal. And the black line, WC plus 30C equals 11,400. So the intersection of these two constraints is that fourth corner point. So we have to solve this system. So I'm going to multiply this by negative 20 and get rid of W. So it's going to be negative 20W minus 20C equals negative 10,000. Okay, and so we have to add these together, and we get 10C equals 11,400 minus 10,000, that's 1,400, and so C equals 140. Okay, now to get W, plug it in, W plus 140 equals 500. Okay, so subtract 140 from both sides, and we get 360. So corner point number 4 is 360, comma, whoop, that's a little messy, 360, comma, 140. Now I'm just going to erase this work so that I have room for number 5. You can probably fit this work in that area to the right of your graph that you have there, okay? So corner point number 5 is the intercept, the green intercept right here. So what was the W-intercept of the green line? It was 500. So you know this is the point 500, comma 0. Okay, so you have your 5 corner points, okay? Here they are. These are the 5 corner points of your feasible region, okay? You have to find, remember, feasible region from Algebra 1, system of inequalities, is the solution. It's where is every single linear inequality true, the area that they have in common, okay? So I'm going to erase this so that I have room, okay? And on your skeleton, okay, below the graph it says optimization. Evaluate the objective function for each of the vertices of the feasible region. Vertices mean the corner points. Here are our 5. So for the optimization part, okay, you take your profit equation, and now you're going to plug in each of these 5 points into this profit equation, and you're going to see which one gives you the most money because you want to maximize your profit. Okay, so that feasible region you have are all of the possible acreages that satisfied our 3 constraints. However, you want to know, okay, I want the WC that satisfies all of these, but at the same time maximizes the profit. And it always happens at a corner point. So we have to take these points and plug them in. So 90 times 0 plus 120 times 0 is going to give us 0. So the amount of profit we're going to make if we don't do any acres of wheat and any acres of corn is just going to be 0. Okay, then 90 times 0 plus 120 times 296. That's going to give us 30 $35,520. So that's going to be our profit if we decide to do no acres of wheat and 296 acres of corn. And this pairing satisfies all of our conditions or our constraints. Number 3, 90 times 180 plus 120 times 260. That's going to give us $47,400. Corner point 4, that's going to be 90 times 360 plus 120 times 140. $49,200. And 5, 90 times 500 plus 120 times 0. That's going to give us $45,000 of profit. So now we look. Which of these is the most amount of money? And the winner is $49,200. And you're going to make $49,200, so that's the maximum profit this farmer can make based on the constraints of the problem. So it says, write a sentence answering the question. So you have to make sure you are answering the question. So I'm going to erase this, and we have to make a nice sentence. And a nice sentence means we do something like this. The farmer can make a maximum profit, I'm just going to write max profit of $49,200 by having, 360 acres of wheat and 140 acres of corn. Okay, and so that is the answer to the problem, and that is linear programming.